So this is chapter 12C on solving simple equations. In this chapter, we're going to talk about solving equations for a missing value, and we're going to go ahead and talk about formalities when it comes to solving equations. So just to give you an idea, an equation is basically what you see here, where there's an expression, an equal sign, and then something on the other side. If it was just c plus 7, this would be called an expression. But because we added the equal sign, and you added the 19 on your side, which means it's equal to something, it could be another expression, this makes it an equation. So there's a difference between an equation and an expression. Now we have to solve. So we have to think backwards. It's kind of like in 12b, we talked about solving for the missing number to keep the equation balanced. It's the same idea. How do we keep this statement balanced? So what plus 7 makes 19? Well, if you think about it, it's going to be 12 because 12 plus 7 makes 19. And so both sides are balanced. And therefore, this is the right answer. If it was 13 plus 7, this side would be 20 and the other side would be 19. And, well, that doesn't work. It's not balanced. So therefore, it wouldn't be 13. So at this time, pause and complete the rest. So in B, you would have 35 because 35 take away 10 makes 25. C, 20 plus 50 makes 70. In D, 14 plus 13 makes 27. And then in E, 17 minus 7 makes 10. Now, it's really easy to do these mentally. However, we need to start working on a formal written method so that when you encounter harder problems, that you'll be able to solve them more easily. Because right now it's easy, but we have to train you to start writing these things out with simple problems. So here we go. If you have c plus 7 equals 19, well, what we have to do to solve for the missing number is to inverse it. So what I'm going to do is, since I see that c plus 7 makes 19, I'm going to move it to the other side. The moment it crosses the equal sign, it's going to be inversed, meaning it's going to change signs. So you always have to include the sign that's in front of the number so you know if the number is going to stay positive or negative. So the c, it stays. The equal sign, it stays. And I like to directly stack it so I know exactly where my equal sign is. The 19, it stays. But that positive 7, since it's moving to the other side and it has to become inversed, meaning it's becoming its opposite, it's going to become negative 7. So this becomes 19 take away 7. And if you think about it, yeah, that does give you the answer of 12. So I'll show a few more and see if you can do the rest on your own. Now for B, since you have a variable, take away 10 equals 25. Now, when it comes to algebra, sometimes you want to move the variable, sometimes you want to move the number itself. In the end, we want to make sure that we are able to isolate that variable that we're trying to solve for. We're trying to get it by itself. So if I keep the n here, then I don't have to worry about it. This 10, though, I can move this over here. So again, like I said, you bring down what stays, the equal sign stays, the 25 stays, that negative 10, it goes to the other side, so it gets turned around, inverse, so it becomes plus 10. So your n becomes 35, which makes sense because 35 take away 10 makes 25. And I'll show one more. Then finally, you have this problem, 20 plus j equals 70. Now, again, I want to keep my variable exactly where it is if I can. So there's the j, there's the equal sign, there's the 70. Now I have to move this 20. Now, you see how there's no sign in front of it? Automatically, that means it's a positive number. So when it runs across the equal sign, it inverses and becomes minus 20. So I have to bring down the minus 20. So then J is just 70 minus 20, which makes 50. And that makes sense because 20 plus 50 makes 70. So why don't you go ahead and try to do D and E on your own? So pause. Okay, so if you did this one with the inverse method, we keep our A, we keep our equal sign, we keep our 25, but we move our 14. So that's a positive 14, so it becomes a minus 14. Therefore, A is equal to, oh, oops, I meant this to be 27, my mistake. There we go, corrected before I made a bigger mistake. It comes 13. And then in this one, B take away 7 equals 10. So I want to keep my B, I want to keep my equal sign, I want to keep my 10, and I want to move the negative 7 across so I can get B by itself. So that becomes its inverse, which is plus 7. Then this becomes B equals 17, which makes sense. Now, the question I always get is, how do you know what do you move first? How come you don't move the 10? How can you move the 7? Let me show you. If you're interested, then stay, otherwise skip ahead. B minus 7 equals 10. If I chose to move my 10, If I chose to move my 10 over here, watch what happens. I have a B, I have a minus 7, and I have a minus 10, and well, the other side has nothing. And in order to keep an equation balanced, we have to have something on both sides. So we have a 0. That's all we can do. There's nothing there. So we want to make sure that goal number 1 is we isolate the variable. And then we move everything away from the variable if we can. Okay? And that's